Collision detection. There are two basic ways to think about collision detection. One is in terms of circles, and the other is in terms of rectangles. I'll start with just circles. So if you look at this screen, I got a couple different circles moving around the screen. Some of these are drawn using this circle function, which has an x, a y, and a radius, and then a velocity. I've already got bouncing off of walls working and basic animation working. If I want to add a new circle, I just come down here and I type circle, and I can give it a new position and a speed, and I'll get a third circle on the screen. So what I would like to do is make the circles start bouncing off of each other and maybe start bouncing off of my little car. So the circles use a sort of add drawing thing. My sprite, which is kind of circular, is a different kind of logic. So I'm going to recommend that what I'm going to do is make a new function to handle the collision with the circle. So I'll call that a collision circle. The collision circle is a simple object. It's going to have an X, a Y, and an R. Those are equivalent to the current X, Y, and R that we hand it. And then we check, does this thing collide with some other circle, which would be another collision circle. So we ask, do two collision circles collide with each other? And the way that we check for the collision uses really simple math. So a circle is defined by the distance from the center to the edge. That's traditionally called the radius. So if we have two different circles and we want to know if they're touching, all we have to do is look at their two centers and check the distance and compare it to the sum of the two radii. So I've got the smaller circle's radius and the bigger circle's radius. I have x and y coordinates for each of these. And to get the distance between those x and y coordinates is going to actually be pretty simple. All I'm going to do for that is draw a triangle. First, I'll take the y component of the triangle and the x component of the triangle. And then what I want to know for distance is the hypotenuse. So that's, if you remember, A, B, and C from basic geometry. We know from Pythagoras that A squared plus B squared equals C squared. I'll show you what that looks like in JavaScript. So in JavaScript, what I'm going to do here is I'm going to say, okay, I have some object x, y, r. I'm going to make a method on that object that checks if it collides with another circle. And that will now check, okay, let's calculate the distance first of all. So the distance is the square root of a squared. Math pow is the squaring. So this dot x minus other circle dot x squared plus b squared, this dot y minus other circle y pow 2. Take the square root of all that, and we have the hypotenuse, right? If the hypotenuse is less than the sum of the other circle's radius and our radius, then less than or equal to, then we do have a hit. Otherwise, we don't have a hit. So this is my little collision circle, true or false. I can actually test that. Oops. I wrote a little test function to test it without ever putting it in my circle. So this is a nice little trick. My Python students will be used to me pushing this. I just check, okay, if I have a circle at 10, 10 with radius 10, does it collide with a circle at 50, 50 with radius 5? And the answer should be no. If I have a circle at 10, 10 with radius 10, does it collide with a circle with 12, 12, radius 12? And the answer should be yes. I can run that function just by calling it there, test collision. And now I should see, oops, except the console's disappeared. Well, that's too bad. My whole interface has disappeared here. Well, anyway, if I had the console, I would see it. I don't know why the console went away, but you would see print out yes, true, and no, false. All right. So I built a simple circle collision detector. You could make that different. If you preferred, you could make a function that took, function do circles collide, and you could have x1, y1, r1, x2, y2, r2. That would be perfectly fine too. And that would look almost identical to this, except these thises would become x1, x2, y1, oops, y2, r1 plus r2. So this would be the same thing, just in maybe a simpler function. XYR, XYR, do circles collide. I don't care. Whichever style you think is clear is fine with me, whatever you want to use. Okay, so now I've got a circle function, circle constructor. Apparently I left an extra bracket. There we go. All right, now I have a circle function already built in. So if I want to check, do the circles hit the other circles, I need some way of keeping track of all the circles in the game, right? So a simple way to think about this would be I could, yeah, apparently I can't save my work here because the interface disappeared. This is high stress programming. All right, so I'm going to go ahead and build a list to contain all the circles I create. So now every time I add a circle, I'll just add it to the list. This could be a problem for a complicated game. You might have to keep track of them if you get rid of them, etc., etc. But I'm just making a simple game, so I'm not going to think too hard about it. All right, so there we go. Now I have a list with all 3 circles. I had a check walls function, so I'll just make a check collisions function. And that will check my other collisions. So let's go ahead and write that. All right, check collisions. So what do we have to do? I have to go through the circles in my list. So I'll do circles for each. This is function other circles. So once for each circle in the list. First thing I have to check is I have to make sure the other circle is not my circle because I'm actually in the list, right? So C here is in the list. So as long as it's not the circle I'm looking at, I'm good. So if it's not the other circle, and now I have my choice of styles. Maybe I'll use the simpler functional one. I'll use this do circles collide if you prefer that. We could use either one here. Do circles collide. So now what are the all these values? So x1 would be this dot x, this dot y, this dot r, and then these ones would be other circle dot x, other circle dot y, other circle dot r. So now I have to decide what happens if they do collide. So there's an if statement that says, do they collide? And some different things could happen. A natural thing to happen would be that we lose our, different physics we could do. So I could make my direction swap. So that'd be a simple thing to do. So I could take this dot vx and multiply it by -1, and this dot vy and multiply it by -1. We'll see if that works. Oh, I made a classic mistake. Haha, this doesn't refer to what I think it does. There we go. Now it does. There we go. So that's one kind of physics. It's not perfect. The circles kind of just change directions when they hit each other. If I wanted to, I could actually bring in the velocity from the other circle. Let's see what that feels like. This dot vy plus equals other circle dot vx. Vy. So now they'll collide into each other. Whoa! And of course, they didn't separate, so they accelerated each other infinitely. So that was pretty good, but then I had to end the collision, which I didn't do. So I guess if I wanted to make this work, I would have to make sure this only happened once per collision. Don't necessarily feel like doing that in this demo. That's some more fancy physics. So let's do the -1 and add it. I wonder what that would do. Oops, I forgot the equals up there. So now it sort of bounces. Yeah. All right, well, not too bad. We could do some more fancy collision physics, but let's go with the -1s for now. All right, so the last step would be making that car also collide. So if I want the car to collide when it hits, I would need to notice when its circle went over there. So let's go down to my sprite. And it already has an update function. So the car can check all the circles, right? So that we can do circles for each. We look at each circle, and if I gotta remember what I called my function. Do circles collide? And this takes an x, y, r, x, y, r. So circle x, circle y, circle r. And then I have to decide what the circle is for my sprite. So probably it's going to be something like the center will be sprite x plus sprite.target width over 2. Sprite y plus sprite.target height over 2. So that would be the center of the sprite. And then I'll draw the circle based on, let's say, the width. So sprite.target width over 2 would be the radius. So that would tell me if they collide. And if they collide, well, it's up to me to decide. Let's make the sprite.y plus equals 10. So we'll just make it fall down every time it collides. All right, well, I've successfully crashed this thing, and I crashed the interface. So I'm going to do a select all and copy, refresh my browser window. Select all and paste. All right, now I can see where my error was. Or can I? Luckily I can hit save. Check debug mode quickly. Oh, I forgot a parenthesis in that if statement, that's all. All right. All right, so if the circles collide, we'll bounce the sprite down. Apparently I have another error. Oh, I moved the parentheses. I hadn't deleted it. It had fallen down. There it was. All right. Now we just need our car to get hit by a ball. All right, and I could sit here all day waiting for this to happen, or I can just make a ball ready to hit the sprite. So the sprite starts at 100, 100. So let's put one at 85, 75, moving at 10, 10 with radius 10. I think that should hit it. Let's see. Oops, I left a comma off. Oops, didn't move fast enough. Try it again. Man, I missed it. Oh, I see. It's stuck against the other ball. That's what happened. There we go. You notice him getting hit there? That worked. So it did get hit. Oh, there he's getting knocked down. Boom, knocked right off the stage. All right. So the game works now. There we go. You can watch it again. And I got basic collision detection. You can see making collision detection work well is tricky. We'd have to build in some more physics. We'd have to check. I guess the biggest thing is to prevent collisions from happening more than once. So once a collision happens, you move it out. And that logic can be a little tricky. It's worth abstracting out. Maybe in a future lesson I could talk a little bit more about how to do that. But I better end this one now.